the Introduction to Magnetism lab, students build off their experiences conducted in the static tape electricity lab. What they're going to do is they're going to continue their investigation into magnetism and to see if it relates at all to electricity. So what do you need to get started? The supplies are listed, and really what you need is a bar magnet. And you're going to ask students to investigate magnetism through an inquiry method, giving them questions to answer. So you might just start with everyday objects and ask them, is there any interaction between this object and the magnet? So as you can see, it does stick. And of course that's at the one end. I could say, well, does it stick at the other end? It does that as well. Does it stick in the middle? It even sticks in the middle. Okay? So while I have that one object, I could take like an eraser or something like that and just say, does that stick? And it doesn't. This will get students started into their investigation into magnetism. So in this activity, students will simply be experimenting with magnets to see how they interact with different materials as well as other magnets. It might be useful to have a magnet that can be suspended, something like this. So I have one that'll spin around. You can get items like this from science supply companies that allow you to suspend them. If you use something like this, make sure you're taping the magnets on there so they don't fall. And what we want to look at now is how those magnets might interact. So I want to see how these magnets might interact with different materials. I can get rubber bands and staples and pens and pencils and paper clips and all those types of things, which are great. But you may want to have students do a more focused investigation so that they might say, well, it seems like metals would affect them. And so I have some metallic strips like this that I got from our chemistry department. They use these as electrodes for the wet cell lab. And a lot of times you can get a set of them from the chemistry teacher. They'll give them to you without a problem. And you can just say, well, that does seem to have some interaction. That was nickel. And let's see, this is a different type of material, a little bit of lead. That doesn't seem to interact. How about copper? No interaction there. How about iron? There's a little interaction, okay, as it catches on. And how about stainless steel? And so what this allows us to do is to see that different types of metals interact with magnets in different ways. If you're looking for a way to extend the lab a little bit more, you can get some neodymium magnets. They're really small magnets, but they are very strong. And so you can actually see how strong the magnet is. Kids love to play with these. You can get them at most science supply houses, and they will add to the strength of the magnets that the students are actually trying to interact with. And so when they go back and they use like stainless steel, you can see, well, it clearly does stick. It's a little easier. And then as we get a different type of material, again, it does stick. But when I get the copper plate, it doesn't stick. Now let's consider how to use the packet. If you look at it, there are 7 questions facing the students. So one option is to have students investigate all the different questions. Another might be to use a jigsaw type activity where you assign students in a group to investigate one of the questions in detail and then to present the results to the class. And in another video, you'll be able to see some ways that students might be able to present their work. Finally, there are a few challenge questions, and those challenge questions are great. They ask, if you only had one magnet and the poles weren't labeled, could you figure it out? So as a way to challenge the students, you could do that. You could cover up the North and the South Pole for them, put a little tape or paper over top of it so that they can't see, and ask them to do it. In another case, they ask, if you have a magnet and something that's not a magnet, can you identify which one is the magnet? And again, it would be great if you could get a magnet that didn't have North and South labeled on it. In case you're wondering, what you do is you connect them as a T, and what you'll see is that it does connect this way, so the magnet is the one that I'm holding, and that if I go like this, it doesn't, and that's because this doesn't have a pole at the end. One aspect you want to be sure to go back to is the goal of the lab, which was to investigate magnets but compare it back to what we did in the tape lab. So you want to make sure that you have students think about what happened in the tape lab and compare that to what happened in this lab. What are the similarities? You could ask, what are the differences? Those types of questions are great at getting at that role, that interplay between magnetism and electricity.